Let's now go into C++ Builder 10 Seattle and look at some example apps on how to use these Intercept Event Handlers to encrypt and decrypt data and streams in AppTethering applications. So using AppTethering, this desktop cast project is a sample application with a client-server architecture where a client application can connect to a server application and receive a screenshot taken by the server application once or every 5 seconds, all using AppTethering to do this. The server application is a Windows VCL application, and the client application is available both as a VCL application and as a FireMonkey application. In the server application, we have a Take Full Screenshot button that takes a screenshot and shows the screenshot. The Start Live Cast button starts taking screenshots every 5 seconds and showing them. The Stop Live Cast button stops taking screenshots. In the client application, we have a Connect button that establishes a connection to the running server application. Clicking the Connect button calls the AppTethering Tether Manager's Auto Connect method that starts the automatic connection to remote managers on each registered adapter, either using network Wi-Fi or Bluetooth Classic. When the connection search finishes, the Tether Manager's event on-end auto connect fires, and you get a list of other app-tethered app profiles that you can connect to, and we display the connected app profile that we are connected to in the caption of the label at the top of the application. On the client app, the Take Full Screenshot button executes the server action to take a screenshot remotely using AppTethering. Clicking the Start Livecast button executes the server action to start taking screenshots every 5 seconds remotely using AppTethering. And clicking the Stop Livecast button on the client executes the server action to stop taking screenshots, also all using AppTethering. When the server application takes a screenshot, the server application shows the screenshot on its T-image component and also shares the screenshot with the client application that also shows the server screenshot on its T-image component. But before the server sends the stream screenshot to the client application, we want to encrypt the stream screenshot before sending to the client, and then when the client receives it, we want to decrypt the stream so we can view it. These applications are sharing stream resources between each other, and to create a stream resource, we use the Tethering App Profiles property called Resources to create the stream. So we created a stream called Bitmap Cast with a resource type of stream. The other resource type is data. So using AppTethering, you can send data and or streams between other app-tethered applications. But for these applications, we're only going to share stream resources. These apps also have an edit box to allow you to enter in the password text to be used by our encryption algorithm to generate the key for the encryption and decryption of the screenshot streams as they are being sent to the app-tethered connected apps. The AppTethering sends the stream resource from the screenshot to the connected tethered apps when there is a change in the resource stream. But before the stream is sent, the Tethering App Profiles Intercept Event Handler called onBeforeSendStream fires, and here is where we can encrypt the stream, and in this case we're using an encryption called Raindoll from the Lockbox library to encrypt the stream. Raindoll is the block cipher algorithm that has been selected by the United States National Institute of Standards and Technology as the candidate for the Advanced Encryption Standard, AES, and it's included in the lockbox library. So this is the on before send stream intercept event handler that we use for the post-processing of the stream data that occurs before the application profile sends the stream to the remote application. So here is where we encrypt the stream data, and then we put the result in a output stream. On the connected client app tethering apps, the tethering app profiles on resource update and or on resource received events fire since we received a new or updated data resource stream. But before the stream is received by the connected client tethered apps, the tethering app profiles intercept event handler on after received stream fires, and here is where we can decrypt the stream using the same Rain-Dahl algorithm for decryption from the lockbox library. It's important to mention that you can use any custom encryption to encrypt and decrypt data and or stream resources using AppTethering using these new intercept event handlers. For this example, we use the lockbox Rain-Dahl encryption with streams. But once again, any custom encryption can be used with AppTethering and these new intercept event handlers. Let's now run these apps and see how they work. Let me first run the AppTethering server app. And now I'll run the AppTethering client app. The two AppTethering apps are running. On the AppTethering client app, I will click the connect button, and this establishes a connection to the running server application by calling the AppTethering tethering manager's auto connect method, and that starts the automatic connection to remote managers on each registered adapter. In this case, I'm using network Wi-Fi, or I could have also used Bluetooth Classic. And when the connection timeout is reached, the tethering manager's event on end auto connect fired, and that gave us a list of other app tethered app profiles that I can connect to. And here we display the connected app profile that we are connected to, which is our AppTethering server app. On the AppTethering server app, I'll click the Take Full Screenshot button, and this takes a screenshot, and it shows the screenshot on the app server app, but it also sends it to all the AppTethered connected client apps. But we know, using AppTethering now, before the stream is sent to the AppTethered connected apps, the intercept event handler on before send stream fires, and that allows us to encrypt the stream before sending. And then when the client receives the stream, we use the intercept event handler on after receive stream to decrypt the stream, allowing us to view the stream on our client apps. So all of this is working great.